Good morning, everyone. I am Adi Mahmoud Islam, one of the interns for fall 2021 in the Urban Robotics Lab. I will be working in the autonomous vehicle division, and my team project leader is Song Chang-ki. So, for this semester, my project is to write a C++ code to generate optical trajectory for dynamic street scenarios in Fernet frame. So in the Fernet frame, the coordinates are placed on the dynamic are placed on the vehicle. So the Fernet frame simplifies the representation of the trajectory from Cartesian coordinate. So for example, a curved trajectory in the Cartesian coordinate would be a straight line. Uh, would be a straight line in the Fernet frame, given that there is no lateral offset. So in here we can see the blue line is the reference path and the red line is the trajectory generated to follow the blue line as closely as possible and also to react to any obstacle that the vehicle faces. So here, given the initial and final pose, we generate a set of trajectories and then we calculate the cost function for all the trajectories. The cost function, the target of the cost function is to minimize the jerkiness of the overall motion, so that uh, the vehicle's motion is relatively comfortable. So out of all the trajectories, we rate each trajectory by calculating its cost and check it if it's valid for any collision. So for example, in here we see that it follows the reference path, but whenever it sees an obstacle, it chooses a second or third best trajectory which is valid for the given collision, i.e. it does not collide with any of the obstacle. This paper is relatively old, and this is a very popular path planning algorithm. However, most of the open source code available online are written in Python, and for our use in the lab's autonomous vehicle, it's not fast enough to use for real-time use. So as a result, our objective for this semester is to rewrite this algorithm in C++. Then we are going to test it on the Carlo simulator, and after it checks that, we are going to test it on the lab self-driving vehicle. So this is the roadmap for the internship plan. So last month, that is in September, I read the relevant papers related to path planning, related to this path planning algorithm. I also read up. I also had some lack of knowledge in the field of vehicle dynamics as well as path planning. So I read some articles and then some chapters from a book by David Scaramuza. Also, I joined the raw study that was provided by the lab, and it helped me to get better in ROS, which will be useful to test my code. And also, I used this time to get myself familiarized with the Crawler simulator. So this was what I did in September. In October, I plan to start the code review of the code available online in Python, and then I will start to rewrite the code in C++. My target is to finish writing the code by November and then test it on Carla by that time, and hopefully by December I can finish the entire project and test the code on the vehicle. So this is my plan for this semester. I would appreciate if anyone has any feedback on my plan. Thank you, and I'm looking forward to this semester.